What you just saw was a scene staged from a movie. However, every day in this country, accidents occur in work zones that kill or seriously injure drivers, passengers, and workers.
About 11:20, I was in one end of the job site working on some time sheets, and I heard one of the trucks come in and approach the job site.
The truck was coming down number 11, and the guy was standing there holding the flag on him, and he had the stop sign on him, and the truck started stopping. But he apparently thought the limo was going to turn the sign on him, and he didn't slow down enough. And he got up close to him, and the limo turned his back on him, and that was a mistake.
And all of a sudden, there was a bump and a skid. I looked around, and the truck had skidded all the way around the road in a perfect U-turn. Of course, there was dust flying then from where it had skidded around, and my grader operator, Brian Harper, was there with me, and he went on up to where the truck was at.
I was watching, and I couldn't really see the flagman, but I could see his sign. He was well off the edge of the road by 5 or 6 feet, and I think he saw the truck coming, but within 20 foot of him, the truck swerved off the road and hit him.
The guy tried to stop the best he could, and the limo turned his back on him, and when he turned back around, the truck was so close on him, there's just nothing he could do. I tried to warn him, tried to holler, but I couldn't holler loud enough to get his attention. And it was all over with in just a matter of a few seconds.
If this truck, the victim had seen the truck in just 1 second earlier, he could have jumped out of the way. But it was a matter that it was a quick move then, and he just didn't have time.
It's kind of hard to stand there and look at somebody get killed that you've known, for all your life, just about it.
11:20 that morning, that little instance happened, changed a lot of people's lives.
You know, it's easy for most of us to forget about traffic control when we're concerned with getting on with the job, whether it's patching potholes, sealing cracks, or other type of pavement repair. We naturally want to spend as little time as possible when setting up traffic control in our work areas. But as you've just seen, work areas are extremely hazardous places. Last year alone, over 700 people lost their lives in work zone accidents, and every day you're on the job, the potential for injury or even death is always there. This training will help you reduce the risk of accidents in your work zones. The focus will be on traffic control in short-term work sites, which will be occupied for no more than one work shift. This training is primarily for daytime operations. The training is divided into 6 parts. This first part will introduce you to some general ideas on work zone safety. Part 2 will present the traffic control devices available to you, while Part 3 will discuss the concepts and elements of traffic control zones. Part 4 will cover several typical applications which you may encounter in your work. Part 5 will demonstrate good flagging procedures. And finally, Part 6 will discuss legal liability issues involving work zones. Now, let's get started. Your safety and the safety of others is your primary concern when setting up traffic control. Whenever work is done on or near the roadway, drivers are suddenly faced with changing and unexpected conditions. Now, if the drivers are not properly warned of these changes, accidents can and will occur, so protective measures must be taken. Liability is a second concern you should have when establishing a traffic control zone. Today, more than ever, work zone accidents are becoming courtroom lawsuits. These lawsuits usually result in large sums of money being awarded by public agencies to those injured. You should take note, though, that even employees are sometimes held liable for damages. A third consideration when you're on the job is image. Not only is safety important at the work site, but so is the way the public sees you and your agency. A professional-looking work crew and properly installed traffic control devices will improve your agency's image and increase the traveling public's respect for your work zone. So safety, liability, and image are 3 points you need to keep in mind when setting up traffic control at your work zone. You should also remember that drivers don't make the distinctions between construction, maintenance, or utility operations, so we need proper traffic control for all types of work. Now, let's discuss some basic concepts that will help you do your job safely. To begin, you'll need access to the Manual on Uniform Traffic Control Devices. This manual is the national standard for all traffic control devices. It applies to all streets and highways open to public travel, and it serves as the standard for state and local manuals. Part 6 of the Manual on Uniform Traffic Control Devices covers traffic controls for street and highway construction, maintenance, utility, and emergency operations. It includes illustrations and layouts for several specific work zone applications. Your state or local agency may have also prepared a supplemental manual which shows additional specific applications and layouts. Many of the typical work sites you'll encounter are illustrated in the Manual on Uniform Traffic Control Devices. However, the manual does not cover every conceivable situation. Good engineering judgment must be used to determine the best traffic control for a particular work site. This will depend upon the type of work needed, the location and duration of work, the type of roadway, traffic volume and speed, and any potential hazards. The principles which you should follow to improve the safety of motorists and workers in short-term work areas include the following. First, keep safety of motorists, pedestrians, and workers your top priority. Try to keep traffic conditions as normal as possible, and take the time to plan and install a traffic control scheme. Sometimes this may mean spending almost as much time in setting up traffic control as you spend in completing the work. Second, minimize interference with traffic movement. Try to maintain the safest maximum speed while eliminating abrupt lane closures. Also provide enough room for work equipment and vehicles inside of your work zone, and then open the roadway again as soon as possible. Third, present a clear, easily understood message to drivers and pedestrians. Now, this means knowing the exact meaning of each traffic control device that is used. It also means that any conflict in meaning between temporary control devices and those permanently in place must be resolved. For example, you may need to close a lane for maintenance. All of the normal road conditions may guide the driver into the closed lane. Therefore, a special effort must be made to overrule the regular message during the duration of the work. Fourth, have a plan in mind before going to the work site. The foreman generally takes on responsibility for designing, installing, and maintaining the traffic control plan. Now this includes keeping the control devices in good repair and properly stored so that adequate visibility is maintained. As soon as the project is finished, you should promptly remove the traffic control devices. Fifth and finally, anticipate the increased hazards caused by your presence on or near the roadway. Be sure to keep your equipment, materials, debris, and yourself out of the path of traffic. This means try to keep a clear roadside through the work area. Use traffic control devices that are lightweight and yielding to lessen vehicle damage. The traffic control devices selected to assist motorists must satisfy a driver's need for information. You should carefully consider both the message and the placement of the traffic control devices. Inappropriate messages and incorrect placement of signs, markings, and other devices can mislead and confuse the motorist. In work zones, there are 3 categories of messages which must be conveyed to the driver. These include the warning of potential hazards, information on safe speed, and the lane or shoulder over which a vehicle should be traveling. Drivers have particular problems when traffic control devices give inaccurate information, do not conform to standards, or are improperly installed. Each person whose actions affect maintenance and construction zone safety should receive training. They must know the following principles. Keep the motorist's respect and the agency's credibility by presenting clean and well-maintained traffic control devices. If work is not in progress or a hazard is not there, take down, fold over, or cover the signs. Don't mislead the public. Remove channelizing devices when no longer needed. Don't tell drivers to expect a hazard that's not there. If you do, they may not believe other signs and devices used on the project. For example, don't use this sign unless flagging is actually taking place. Put yourself in the driver's seat and see how the traffic control looks to you. Maintain the controls as if every driver were approaching the area for the first time, especially in short-term work sites. Discuss and think about good work area traffic control. Help your co-workers to perform their work with a minimum of exposure to traffic while watching for problems and reporting any damaged or missing devices. Now, let's review what we've discussed in this introduction to work zone safety. Here are the main points to remember. 1, Part 6 of the Manual on Uniform Traffic Control Devices is the standard for traffic control in your work zones. 2, it may be supplemented by state and local manuals, and these should be consulted before setting up a work zone. 3, plan your traffic control before going to the work site. Good planning includes carrying the proper signs, cones, and other devices needed to safely do the job. Be sure they're clean and in good repair. 4, only display those devices that are needed by the driver. If the work zone traffic control device is not needed, remove, cover, or lay it down as soon as possible. Don't mislead the public. 5, always ask yourself, how does it look to the unsuspecting driver approaching my work site? What's the driver's view? We've taken a look at the reasons for proper traffic control and its relationship to safety in the work zones. Now, in the following parts, we'll be reviewing the concept of traffic control zones, the types and uses of traffic control devices, and we'll be reviewing some typical applications that you'll be using in your work. Traffic control devices include signs, signals, lighting units, pavement markings, delineators, channelizing units, and hand signals or flags, all of which are used to warn, guide, or regulate traffic. Now, in this part, we'll discuss elements of design, proper application, and placement for these devices. Signs are classified as regulatory, warning, and guide signs. Regulatory signs impose legal restrictions and may be used only with permission from the authority having jurisdiction over the roadway. There are several types of regulatory signs. Some are typically rectangular, with the long dimension vertical. The standard color scheme is black lettering on a white background. A red circle with a diagonal slash may be used with a black diagram to indicate a prohibitive maneuver. Red is used as the predominant color for stop, yield, do not enter, and wrong way signs. The unique shapes and color schemes increase the attention-getting value for these important signs. Warning signs are used when conditions are potentially hazardous to traffic. They should be used when such conditions are real, particularly when the danger is not obvious or cannot be seen by the motorist. Most warning signs are diamond-shaped with one diagonal vertical. One exception is the advanced railroad crossing warning sign, which is round. Permanent warning signs have a black legend on a yellow background, while construction and maintenance warning signs are a special series with the black legend on an orange background. The orange color indicates a temporary condition and the potential hazard of the work site. Warning signs should be placed well ahead of the site to give the motorist enough time to understand and then respond to the information. Guide signs show destinations, directions, services, points of interest, and other geographical or cultural information. Informational signs are required at work zones for standard route markings when temporary route changes are necessary. Directional signs and street name signs are used with detour routing and may have a black legend on an orange background. Special information signs relating to the work being done also have a black message on an orange background. Some examples are road construction next 5 miles, end construction, detour, pilot car, follow me. Standard signs and messages, as shown in the manual on uniform traffic control devices, should always be used. You see, drivers are familiar with those signs and they know how to react. But non-standard sign messages could be confusing. All signs should be made in a professional sign shop or purchased from a reputable business. Now, homemade signs are immediately suspect and do not command driver respect. Now, when choosing signs, the following should be considered. Choose signs that are appropriate, that accurately describe the work situation. Use your common sense and the manual on uniform traffic control devices in selecting signs. Use specific warning signs to warn of specific hazards, not general signs that simply say men working. The message on signs should tell what action the driver needs to take. Use larger signs when greater visibility is needed, especially with high speed or volume. At the beginning of the work area, start with an advanced road work ahead sign. Then use signs with more specific messages, with the most specific sign stating what action should be taken by the driver closest to the work area. Drivers sometimes forget what they're told, so the last sign in the advanced warning area should tell them specifically what to look for or to expect, such as a flagger or a right lane closure ahead. The message ahead is generally used on the warning signs for short-term work sites. The overall effect of the signs should make the driver aware of what he or she is approaching and what action will be required. In keeping with the manual on uniform traffic control devices, a rule of thumb for the spacing between signs in a series is 200 feet for 2-lane city streets, 500 feet for rural roads and multi-lane city streets, and 1,300 to 2,600 feet for freeways. Lightweight, yielding, or breakaway supports should be used for all sign installations. Sign installations should be reviewed to avoid any possible glare from vehicle headlights. The minimum height requirements for signs attached to posts is shown. Signs on portable supports are required to be at least 1 foot above the roadway. All signs used at night are required by the Manual on Uniform Traffic Control Devices to be retroreflective or externally illuminated. Lighting from existing streetlights does not meet this requirement. Pavement markings are very important in guiding traffic through work zones. Pavement markings, delineators, and channelizing devices outline the traffic path around a work area. Drivers use pavement markings as a primary means of guidance. The standard markings planned for the road should be in place before opening a new facility to traffic. Also, if revised lane patterns are planned for the work zone, temporary markings should be placed before the traffic is changed. Where this is not feasible, such as during the process of making a traffic shift or carrying traffic through surfacing operations, temporary delineation may be accomplished with lines of traffic cones, other channelizing devices, or short strips of adhesive-backed reflectorized tape. When pavement placed during the day is to be open to traffic at night, and permanent striping cannot be placed before the end of the workday, a temporary stripe should be applied to indicate to the driver the location of the lane or center line. Channelizing devices are used to warn and direct traffic away from or around a work area. They also control the flow of traffic when separating two directions of travel. They include barricades, barriers, vertical panels, cones, tubular markers, and drums. Each type has distinct visibility characteristics and advantages. The Manual on Uniform Traffic Control Devices requires that channelizing devices used at night be reflectorized with a material having a smooth, sealed outer surface. This includes commercially available reflectorized sheeting and tape strips. It does not include the use of pavement marking tape. Some devices are easily knocked down and require a weight, such as a sandbag. These weights must be placed at the bottom of the device for stability and to keep the weight from being thrown if hit. Neither the device nor the weight should cause excessive damage when struck. Sandbags should not be placed where they will be a hazard to the driver or limit the view of the device. Cones are lightweight channelizing devices that may be stacked for storage. They are easy to place and remove and are a minor impedance to traffic flow. For stability, a rubber or sand collar or a specially weighted base may be added. When purchasing cones, specifications may require 60% or more of the weight in the base, thus removing the need for extra base weights or collars. Cones cause little or no damage when hit. They must be at least 18 inches high, but 28-inch cones must be used on freeways and other roadways where speeds are 45 miles an hour or greater. At night, 28-inch cones or larger should be used. 28-inch cones must have a 4-inch wide band, 2 inches below a 6-inch band. Any cone height less than 28 inches is not acceptable for nighttime use. Using cones can have disadvantages because drivers have less respect for them, and cones can be easily displaced or knocked over unless properly ballasted. Now, when cones are used, they should be checked periodically, and those that have either been displaced or knocked over should be reset. Tubular markers are similar to cones in that they are lightweight, easy to install, and are a minor impedance to traffic flow. Tubular markers may be set in special weighted bases or fastened directly to the pavement. Because of their narrow size, they offer a particular advantage when forming new lanes or separating two-way traffic for a short-term activity. Tubular markers are at least 18 inches high, with taller devices preferred for better visibility. If used at night, the Manual on Uniform Traffic Control Devices requires that they be retroreflectorized. Tubular markers have the same disadvantages as cones, plus having less visible area. Vertical panels are used as either channelizing or warning devices, but are not as portable or easy to install as cones or tubular markers. They are useful in narrow areas where barricades and drums would be too wide. Vertical panels should be mounted on lightweight posts, driven into the ground or placed on lightweight portable supports. They may be mounted back to back and used between opposing lanes of traffic. Drums are used as either channeling or warning devices. They're highly visible, give the appearance of being formidable objects, and therefore command the respect of drivers. Plastic, not metal drums, should be used. The manual on uniform traffic control devices requires that markings on a drum be horizontal orange and white stripes that are reflectorized, 4 to 8 inches wide. The drum must have at least 2 sets of orange and white stripes, but can also have non-reflectorized spaces of up to 2 inches wide between the stripes. Plastic drums can be easily nested, allowing for easy transport and storage. Many of the plastic drums available have 1 or more flat sides to prevent rolling, and have flanges or recesses for warning lights. Barricades should be constructed of lightweight materials and are classified as types 1, 2, and 3. The type is determined by the number of reflectorized rails facing traffic. Types 1 and 2 are portable and can be used for either channelizing or marking hazards. Type 3 barricades are used for road closures. Types 1 and 2 have rails on both sides and may be used to separate opposing lanes of traffic. The rails have alternating orange and white reflectorized stripes that slope down toward the side traffic is to pass. For road closures, a road closed sign and a detour arrow sign, if needed, may be mounted on a Type 3 barricade. If local traffic will be allowed to use the closed roadway, then the local traffic only sign should be mounted on the barricade. The terms barrier and barricade are frequently confused. Now, a barricade indicates the location of a hazard or a desired path a motorist should take. On the other hand, a barrier provides a positive physical separation between traffic in the work area or between opposing streams of traffic. High-level warning devices are tall, portable stands with flags that are visible above the traffic and parked cars. They have 3 orange flags, 16-inch square or larger, at least 8 feet above the roadway. The devices may be used with a sign or flashing light attached, or they may be attached to vehicles used in moving or mobile operations. Most of the warning lights in use are portable, lens-directed enclosed units and may be used on channelizing devices, barricades, and signs. These are the principal types and uses of warning lights. Flashing lights Type A are used on channelizing devices to warn of an isolated hazard at night or to call attention to warning signs at night. High-intensity lights, Type B, are used on advanced warning signs day and night and with high-level assemblies. Steady burn lights, Type C, are used on a series of channelizing devices or on barriers which either form the taper to close a lane or shoulder or to keep a section of lane or shoulder closed, and are also used on the channelizing devices beside the work area at night. Both Type A and Type C lights have photoelectric switches to activate them at night. Warning lights should be secured in such a way that they'll not separate from the channelizing device or sign when hit by a vehicle. Warning lights that come loose during an accident may become dangerous flying objects. Work vehicles in or near the traffic areas are hazards and should be equipped with flashing lights. The vehicle warning may be emergency flashers, flashing, strobe, or rotating beacons. High-intensity lights are effective both day and night. The flashing lights should meet the requirements of the agency that has jurisdiction over the street or highway. These lights should be used in addition to other channelizing and warning devices. However, in some emergency situations where the work may be in progress for a very short time, these lights may be the only warning device. Arrow panels are signs with a matrix of lights capable of either flashing or sequential displays. Arrow panels are used for moving traffic out of a lane. They may be used at tapered lane closures and with moving operations. They are not a substitute for a lane closure taper. There are two types of arrow panels: flashing and sequencing. Arrow panels have four basic operating modes: left arrow, right arrow, left and right arrow, caution mode, four or more lamps arranged in a pattern which does not indicate a direction. Flashing arrows must never be used on two-lane roadways because traffic may be directed into a head-on collision. Arrow panels on two-lane roads can only be used in the caution mode with no arrows. Flashing hazard identification beacons are used in work areas both day and night to alert drivers of a critical point in the highway, such as a truck crossing, and have the same meaning as permanently mounted beacons. Flashing beacons are not used for channelizations. Portable variable message signs capable of displaying various messages to the motorist will sometimes help construction zone signing. These devices are normally trailer or truck mounted and have their own power system. Because they're expensive to buy and operate, variable message signs are normally used for more complex traffic control plans. When using a variable message sign, be sure the message is clear. A lengthy message may distract the motorist too long. The word order in a message can also cause problems. For example, right lane closed merge would get a different driver response than lane closed merge right. Yet the messages are similar, except for the beginning point. This concludes our brief review of traffic control devices. Particular details will be found in the manual on uniform traffic control devices. Now, in the following section, we'll be discussing the concepts and elements of traffic control zones. When traffic is affected by construction, maintenance, or utility operations, traffic control is needed to safely guide and protect motorists, pedestrians, and workers in and through work zones. This zone is the area between the first advance warning sign and the point beyond the work where traffic is no longer affected. Most traffic control zones can be divided into 5 areas. In this part of the training, we'll look at each of the areas and examine them for one direction of travel. If the work you'll be doing affects more than one direction of travel, the same principles we cover here will apply to traffic in all directions. These are the 5 areas of traffic control we'll be discussing. Accidents can occur in all of these areas if they're not properly controlled. Advance warning area, transition area, buffer space, work area, and termination area. The advance warning area prepares drivers and alerts them to what's coming. An advance warning area is necessary for all traffic control zones because drivers need to know what to expect. Before reaching the work area, drivers should have enough time to adjust their driving patterns. In the advance warning area, traffic control devices may vary from a series of signs starting a mile in advance of the work area to a single sign or flashing lights on a vehicle. The advance warning area, from the first sign to the start of the transition area, should be long enough to give the motorist enough time to respond to the control devices. For most operations, the length can be 1 mile for freeways or expressways, 1,500 feet for most other roadways or open highway conditions, or 1 block or more for urban streets. Next is the transition area. When work is performed within 1 or more traveled lanes, a lane closure is generally required. In the transition area, traffic is channeled from the normal highway lanes to a new path, which is required to move traffic around the work area. Most often, this is accomplished with tapers to close the lanes. The transition area should be obvious to drivers. The correct path should be clearly marked with channelizing devices so the drivers will not make a mistake and follow the old path. If the existing pavement markings create confusion, temporary markings should be used. A taper is a series of channelizing devices placed at an angle to move traffic out of its normal path. There are 5 general types of tapers used in traffic control zones. Merging tapers close a lane of moving traffic on multi-lane highways where a merge is required. The spacing for channelizing devices should not be greater than the speed limit. Lane shift tapers move traffic to a different lane where a merge is not required. Shoulder closure tapers are needed to close shoulder areas. Two-way tapers control two-way traffic, where drivers are required to alternately use a single lane. These tapers are used when flaggers are present. Downstream tapers are those installed to allow traffic back into the normal path.
The length of each type of taper is very important and is determined by several factors. Let's look at each of these factors in more detail.
The length of a merging taper, which is used to close a lane, is determined by the speed of traffic and the width of the lane to be closed. The 2 formulas for determining the length of tapers for lane closures are discussed in the Manual on Uniform Traffic Control Devices. For speeds of 45 miles an hour or greater, the merging taper length should be at least the width of the lane multiplied by the speed limit. For speeds of 40 miles an hour or less, the length of the taper should be at least the product of the width of the lane times the speed limit divided by 60. This is actually the high-speed taper multiplied by the factor of the speed limit divided by 60. In most tables, the equation is shown as this. Most state and local manuals include tables showing the required taper lengths for various speeds and lane widths. For example, a 40-mile-per-hour speed limit and an 11-foot lane requires a 295-foot merging taper. The lane shift taper is used when traffic is only being shifted and no merge is required. Therefore, the taper does not have to be as long as a merging taper. The minimum taper length is 1/2 L, where L is the computed length of a merging taper for the given speed limit and width of the lane shift. When an improved shoulder, having a width of 8 feet or more, is closed on a high-speed roadway, it should be treated as a closed part of the roadway. The shoulder taper should be 1/3 L, where L is the shoulder width multiplied by the speed limit. If the shoulder is used as a travel lane, however, the taper is equal to L. The two-way traffic taper is used in advance of a work area that occupies part of a two-way road when the remainder of the road is used alternately by traffic in either direction. A short taper is used to slow down traffic by giving the appearance of restricted alignment. One or more flaggers or temporary traffic signals are used to assign the right-of-way in such conditions. Two-way traffic tapers should be a maximum of 100 feet long, with channelizing devices spaced at a maximum of 20 feet
to provide clear delineation of the taper. A downstream taper is used at the downstream end of the work to allow drivers back into the lane that was closed. It's placed in the termination area. While closing tapers are optional, they may be useful in smoothing traffic flow. However, they may not be advisable when material trucks move into the work area by backing up from the downstream end. If a closing taper is used, it should be at least 100 feet in length per lane. Here is a table from the Manual on Uniform Traffic Control Devices that shows the lengths for the 5 types of tapers.
Let's briefly review tapers and taper lengths. Where traffic on a multi-lane highway must merge, the required length is the function of the speed limit and the lane width. If traffic on a multi-lane road is to be shifted to a different lane, the taper is 1/2 the length of the merging taper length. When working on an improved shoulder, the required taper length is 1/3 of the merging taper length. Now, when traffic is on a two-way road and it's reduced to one lane, a taper with a maximum length of 100 feet is needed. And to let the driver know that he may return to the closed portion of the roadway, a 100-foot taper may be used.
If restricted sight distance is a problem, for example, a sharp vertical or horizontal curve, the taper should be moved well in advance of the obstructed view. Beginnings of tapers should never be hidden behind curves. Traffic should be observed to see if the taper is working correctly. Frequent use of brakes and evidence of skid markings are indications that either the taper is too short or the advance warning is inadequate. The buffer space is the open or unoccupied space between the transition and work area. The buffer space provides a margin of safety for both traffic and workers. If a driver doesn't see the advance warning devices or fails to negotiate the transition, a buffer space provides room to stop the vehicle before actually entering the work area. The length of the buffer space is based on the stopping sight distance for the speed being considered. The table shows the length of the buffer space for various speeds. This will provide adequate distance to allow the vehicle to stop before entering the work area. The length of the buffer area is measured from the end of the transition area. It is important for the buffer space to be free of equipment, workers, materials, and vehicles. When designing work zones, the following should be considered for buffer spaces. Place channelizing devices along the edge of the buffer space. The spacing should be no greater than twice the speed limit. Situations occur where one lane of traffic uses a lane that normally flows in the opposite direction. In these situations, a buffer space should be used to separate the two tapers for opposing directions of traffic to help prevent head-on collisions. The work area is that portion of the roadway which contains the work activity and is closed to traffic and set aside for exclusive work by workers, equipment, and construction materials. Work areas may remain in a fixed location or move as work progresses. The work area is usually delineated by channelizing devices or shielded by barriers to exclude traffic and pedestrians. Every feasible effort should be made to minimize traffic conflicts with the work area. These are suggestions. Use traffic control devices to make the travel path clearly visible to drivers. For nighttime operations, the traffic control devices must be retroreflectorized and have a large surface area. Place channelizing devices between the work area and the traveled way. Provide safe entrances and exits for work vehicles. Flags and flashing lights should be considered on work vehicles exposed to traffic, and a truck-mounted attenuator be provided whenever possible to protect work crews. The termination area provides a short distance for traffic to clear the work area and to return to the normal traffic lane. It extends from the downstream end of the work area to the end construction or end roadwork sign. A downstream taper may be placed in the termination area. For some work operations, such as single location utility or maintenance repair, it may not be necessary to display an in construction sign because it will be obvious to the drivers that they've passed the work area. Avoid gaps in the traffic control at work zones that may falsely indicate to drivers that they've passed the work area. For example, if the work includes intermittent activity through a 1-mile section, drivers should be reminded periodically that they are still in the work zone. The primary purpose of the guide sign, Road Construction Next Miles, is to inform the driver of the length of the work area. It should not be erected until work begins. In moving operations, the advance warning area may be provided by signs and flashing lights on the work vehicle. Additional advance warning signs may be warranted depending on the volume and the speed of traffic. A shadow vehicle equipped with an arrow panel sign and flashing lights may also be used. With moving operations, the transition area actually moves with the work area, and the buffer space is the area between the shadow vehicle, if one is used, and the work vehicle. The termination area is usually obvious to the driver passing the work vehicle. The use of a truck-mounted attenuator should be considered for moving operations.
Now, as a review, these are the 5 parts of a traffic control zone. The advance warning area alerts the driver that there's something ahead that demands his close attention. In the transition area, traffic is shifted or moved to eliminate interference with work activities. The length of the taper should be computed or obtained from a table. The buffer area provides a margin of safety in case a vehicle runs through the transition area. The work area is for workers, equipment, and vehicles. The objective is to keep traffic out of this area. And the termination area tells motorists they're out of the construction area and may resume normal driving. This concludes the review of the 5 basic parts of a traffic control zone and their function. In the next session of the series, we'll be reviewing some typical applications that you'll be using in your work. We've reviewed the need for traffic control at work sites, examined the traffic control zones, and looked at the standard traffic control devices. Now we want to take a look at some typical applications of work zone traffic control. The various state and local supplements to the Manual on Uniform Traffic Control Devices provide detailed layouts in addition to those shown in the MUTCD. Unfortunately, it's not possible to demonstrate or illustrate all of the possible applications that you'll encounter in your work. Using your judgment and experience, you can adapt these typical layouts by modifying the dimensions in the various diagrams. Remember, in all situations, the primary purpose of traffic control is to warn and guide the driver while he or she is approaching or passing through your work zone.
You are probably most vulnerable during the installation of the traffic control devices. To minimize this hazard, install the devices before work begins, starting with the first device the driver will see when approaching the area. Then continue installing devices, advancing toward the work area. To evaluate any work zone traffic control, drive through the work zone after all the devices are in place. Difficult as it is, put yourself in the place of the unfamiliar driver, the one who's not anticipating that you're in the roadway. If the traffic control scheme gives the driver the necessary warning and guidance, you and your co-workers will be providing the best protection for yourselves while working on or near the roadway. As soon as the work is completed, remove the traffic control devices in the reverse order of installation, starting with the termination area and proceeding back to the first device installed.
The best way to illustrate these principles is to show the installation of the control scheme for some common types of operations.
In the first example, the work is entirely beyond the shoulder or parking lane. Traffic control will generally consist of flashing vehicle lights and flags. An advance warning sign should be used when the work will interfere with traffic in any way. Now, let's look at work on the shoulder or parking lane. If there is no direct interference with traffic, the motorist should be warned with the sign "Shoulder Work," as shown. If a shoulder closure is involved, a transition area should be used. The length of the taper should be 1/3 of the lane closure taper length. In this case, the shoulder width is used for the formula instead of lane width. Remember that the lane closure taper length is the product of the lane width and speed limit for speeds over 45 miles per hour. Let's assume a 55-mile-an-hour speed limit and a 10-foot shoulder. The lane closure taper would be 10 times 55, or 550 feet. The shoulder closure taper is therefore 1/3 of this, or approximately 180 feet. A buffer zone should be provided in advance of the shoulder work area. When work is on the shoulder or takes up part of a lane, traffic volumes, types of traffic, this could be buses, trucks, and cars, speed and capacity should be analyzed to determine whether the affected lane should be closed. Now, the lane should not be reduced to less than 10 feet. You can consult Part 6 of the Manual on Uniform Traffic Control Devices. When one lane is closed on a 2-lane, 2-way road, the remaining lane must be used by traffic traveling in both directions. The short 2-way traffic taper, 100 feet maximum, is used to slow traffic as it approaches the workspace. This example shows work on a high-speed 2-lane, 2-way road, making it necessary to close one lane of traffic. For this example, the speed limit is 55 miles per hour, and the highway is a major arterial route with relatively high traffic volumes. This makes it necessary to use 2 flaggers and to install the 3 advance warning signs 500 feet apart. First, install the Road Work Ahead sign for the unobstructed roadway. This sign is placed at least 1,700 feet in advance of the work area. The second sign, One Lane Road Ahead, is placed 500 feet from the first sign. The last sign installed, the flagger symbol, is placed 500 feet from the second sign. The first flagger then assumes his or her station 500 feet from the flagger sign, placing the first flagger at least 200 feet from the beginning of the work area. The same series of signs are then installed on the side of the roadway on which the work is being done, again starting with a Road Work Ahead sign 2,000 feet from the work area, a 1-lane road sign at 500 feet, a flagger symbol at another 500 feet, and finally, the flagger 500 feet beyond the last sign. At this time, the 2 flaggers began controlling traffic through the 1-lane section. Next, install the second traffic control element, a 100-foot taper, made up of 5 or more channelizing devices. Now, the third element, a 400-foot buffer space, and the fourth element, the work area, are then outlined with channelizing devices, spaced at approximately 100-foot intervals. The work vehicle may then be moved into the closed lane at the end of the buffer space. The 100-foot downstream taper is then installed at the end of the work area. Finally, the end construction sign is placed 500 feet from the work area and completes the work zone. As previously emphasized, the best way to evaluate work zone traffic control is to drive through the work zone after all the devices are in place. Now, the work activity may begin. After the project is completed and all workers, materials, and equipment are off the roadway, the traffic control devices are removed in reverse order of installation. The next example is an urban undivided 4-lane roadway. The work being done makes it necessary to close the right lane of the roadway. If the left lane were to be closed, the layout would be reversed. If the posted speed is 35 miles per hour with 12-foot lanes, then the required lane closure taper would be 12 times 35 times 35 divided by 60, or 245 feet. We'll round that off to 250 feet. The first sign installed for the unobstructed roadway is a Road Work Ahead sign. This sign is placed 500 feet in advance of the work area. The signs for the roadway on which the work is taking place are then installed. The Road Work Ahead sign is placed 1,860 feet before the work area. The next sign is a Right Lane Closed sign, 500 feet from the Road Work Ahead sign. Then, we place a Lane Reduction Transition sign 500 feet from the Right Lane Closed sign. Now that all of the advanced warning signs are in place, it's recommended that you install an advance warning flashing arrow panel. This is done to give you, the worker, added protection while setting up the taper. If there's a shoulder, the arrow should be placed on the shoulder at the beginning of the taper. If there is no shoulder, it should be placed as illustrated. For this application, the lane closure taper will consist of 8 channelizing devices on 35-foot centers for a 250-foot taper. It's a good practice to spot the cones or other devices at the proper spacing on the shoulder and then walk them out into the lane. The third element, a 110-foot buffer space, and the fourth element, the work area, are then outlined on both sides with channelizing devices spaced at 2 to 4 times the speed limit or at 70 to 140-foot intervals. The fifth element installed is a 100-foot downstream taper. The last element installed is the end construction sign, 500 feet from the work area. Finally, the work vehicle may be moved into the closed lane near the work area. Again, the best way to evaluate work zone traffic controls is to drive through the work zone after all the devices are in place. Now the work activity may begin. After the project is completed and all workers, materials, and equipment are off the roadway, the traffic control devices are removed in reverse order of installation. The sixth example will be on a high-speed divided multi-lane highway where the work being done requires the right lane to be closed. The first element installed is the advance warning area, which begins 1 mile before the work area. In the previous examples, the advance signs were installed only to the right of the approaching traffic. However, for one-way multi-lane roadways, the advance signs are generally installed on both the left and right sides of the roadway. The first 2 signs installed are the 2 Road Work Ahead signs, 1 mile before the work area on both sides of the roadway. Next, 2 Right Lane Closed signs are placed 1/2 mile from the first signs, again, 1 on each side of the roadway. Third, a pair of Lane Reduction Transition signs. These signs are placed 1,600 feet from the Right Lane Closed sign. Next, 1,000 feet from the Lane Transition sign, install the second element of traffic control, the Lane Closure Taper. Again, when setting up the taper, place your work vehicle or an advance warning arrow panel before the start of the taper for added protection. With a 55-mile-per-hour speed limit and 12-foot lanes, the taper should be 55 times 12, or 660 feet long. For this example, the lane closure taper consists of 13 channelizing devices on 55-foot centers for a total of 660 feet. The third element, a 120-foot buffer space, and the fourth element, the work area, are outlined by channelizing devices spaced 2 to 4 times the speed limit. For 55 miles per hour, the spacing would be 110 to 220 feet. The fifth element installed is a closing taper 100 feet maximum. The last element, the end construction sign, is then installed 500 feet from the work area. Finally, the work vehicle may be moved into the closed lane near the work area. Again, evaluate work zone traffic controls by driving through the work zone after all the devices are in place. Remember, put yourself in the place of the unfamiliar driver, the one who's not anticipating your presence on the roadway. Now the work activity may begin. After the project is completed and all workers, materials, and equipment are off the roadway, the traffic control devices are removed in reverse order of installation. And finally, mobile or moving operations will be shown. Generally, this work uses a moving vehicle train with occasional stops of less than 15 minutes. Warning signs, flashing vehicle light flags, and/or channelizing devices should be used. Mobile operations should be used only during daylight hours and at locations that offer good visibility. When the sight distance approaching any two-lane mobile operation is restricted, a flagger should be used to protect the work area and to warn the driver. Traffic control for a mobile operation should include signs, flags, flashers, arrow panel, except 2 lanes, and a shadow vehicle. Despite the brevity of short-term operations, certain traffic controls are necessary. In urban areas, the work vehicle may be used for warning if it's equipped with flashing lights, rotating beacons, or flags. When it's necessary to enter or leave a manhole, workers should always station a work vehicle upstream from the manhole. Materials or equipment should be stored away from the manhole opening. These principles presented apply to utility work zones and are just as mandatory as those in roadway work. We have briefly reviewed a few examples of layouts under a number of different conditions. Now, this small number cannot nearly begin to address all the possible situations that you'll encounter. You'll often be called upon to develop your own traffic control plan, providing safety for both workers and drivers. Now, while this task may be time-consuming, it is part of your responsibility that can never be set aside because of the urgency to get on with the job. Your safety, the safety of your fellow workers, and the safety of the driving public will depend on whether you execute your flagging duties properly. You're in contact with the public, and your attitude directly affects the public's perception of operations. This tape was developed as an aid in preparing you to be flaggers. If you ever have any questions on flagging operations, never hesitate to ask your supervisor, because a flagger's responsibilities are of primary importance in maintaining safety in the work zone. Your first responsibility as a flagger is to have the proper clothing and equipment in good condition. Improper equipment reduces the driver's ability to interpret your instructions. Neat dress and appearance also help you gain the driver's respect, making your job that much easier. Your clothes should include an orange vest, with an orange hat or whatever is required by your agency. Your clothing should make you more visible to traffic and make you stand out from the other workers. It's also a good idea to carry an air horn or whistle to alert your co-workers if a vehicle appears likely to penetrate the work area. Safety rules and regulations on flagging vary from one road authority to another, and your supervisor will inform you of any specific requirements for your area. The primary traffic control device used by flaggers is the Stop Slow reflectorized paddle sign, which is octagon-shaped, at least 18 by 18 inches, attached to a staff approximately 5 feet tall. Because drivers are sometimes not alert, fatigued, preoccupied, or impaired, you must remain alert at all times and stay on your feet, facing oncoming traffic. Always stand alone in a highly visible location, away from other workers and work vehicles. However, never stand directly in the path of an approaching vehicle. First, be sure that the flagger ahead sign is properly in place. Next, use your equipment properly. Generally, flagging operations require 3 basic skills: stopping, releasing, and slowing traffic. To stop traffic, stand on the shoulder of the roadway with the stop sign erect and away from your body. Look directly at the approaching traffic and raise your free hand with the palm exposed to the approaching driver. After you have stopped the first vehicle, walk out to the center of the roadway so additional approaching traffic can see the stop paddle. Remember, never stand in the path of oncoming traffic. After traffic is stopped, there are 2 ways to release traffic. The first way is to release traffic into the left lane, and the second way is to release traffic into the right lane. To release traffic into the left lane, remain standing in the closed lane, turn the slow side of the sign to face the vehicles, and with your free arm, signal the drivers to proceed in the left lane. Never wave the sign. After all the vehicles have passed, return to your original position on the shoulder to wait for the next vehicle. Now, the second way to release traffic is into the right lane. After you've stopped the traffic and are standing near the center line, return to your position on the shoulder. Display the slow sign to the driver and, with your free arm, motion the driver to proceed. In some cases, it may not be necessary to completely stop traffic, but only slow it down. In these cases, always stand on the shoulder of the road, display the slow paddle to oncoming traffic, and use your free arm to motion traffic to slow down. Remember, never stand in the path of oncoming traffic. These 3 basic skills are the only actions you need to know for a successful flagging operation. Situations will vary, and how you apply these skills will differ from project to project. This second part will cover some typical situations a flagger may face. However, before starting any of these operations, advance warning signs should be set up before the flagger actually starts controlling traffic. These signs tell the driver that you're controlling traffic up ahead. Without these advance warning signs, the driver does not expect you to be on the roadway. Once the advance warning signs are in place, you may begin flagging. The first situation that requires a flagging operation is that of an advance flagger who is placed well ahead of the work area. As an advance flagger, you should stop each vehicle and advise the driver of the situation ahead and any appropriate action required. Always be alert, considerate, and avoid any unnecessary conversation. The second situation is a one-flagger operation. Sometimes it may be acceptable to use only one flagger to control traffic on a 2-lane road. A one-flagger operation should only be used on a low-volume, low-speed roadway with good visibility at the work site. The work area should also be relatively short. In a one-flagger operation, the flagger stands on the shoulder opposite from the work area. The flagger should stand in a position visible to traffic approaching from either direction. In this position, the flagger can assign right-of-way with the sign paddle. The third situation, probably the most common, is the two-flagger operation. In these cases, one flagger is always in charge to coordinate the operation. When two flaggers are used, they must always be able to communicate with one another. This can be done with two-way radios, flag carrying, or sight method, where both flaggers must have visual contact. The first flagger releases traffic and displays the slow paddle, while the second flagger stops and holds traffic until an all clear is received from the first flagger. This allows the second flagger to release the stop traffic. In this example, the flag carrying method of communication is used. The first flagger hands a flag to the last car he allows to go through. When that driver reaches the second flagger, he hands him the flag. Having received the all clear, the flagger can now allow traffic to flow safely in the opposite direction. This operation is very simple. However, communication between flaggers is imperative, and the flagger must be assured that the driver of the last vehicle will pass the flag to the other flagger. The fourth situation presented is nighttime flagging operations. These procedures are generally the same as daytime, except for some equipment changes. A flashlight with glow cone, a retroreflectorized vest, and a retroreflectorized stop-slow paddle are required for nighttime flagging operations. The flagger station should be illuminated by auxiliary lighting. The more visible you are, the easier it is for the driver to see you and to follow your instructions. To stop an approaching vehicle, stand on the shoulder holding the stop paddle away from your body. Do not stand in the traveled lane. Wave your flashlight or lantern back and forth in front of your body by holding the sign paddle in the usual manner. To release traffic, use the same procedures that you use during daylight hours. Do not wave the flashlight. This might confuse the drivers. The fifth situation involves only one flagger restricting only one direction of traffic. An example of this is in an area where trucks are loading and unloading and are partially blocking the lane. The flagger stops traffic in the usual manner. Once the work has been completed and the way is clear, the flagger releases traffic. When releasing traffic on a two-lane highway where traffic is stopped temporarily only in one lane, such as for loading or unloading operations, the sign standard should be turned a quarter turn so that the letters "Stop" face you as the flagger. In this position, the sign should be parallel to the shoulder of the road so that neither "Stop" nor "Slow" can be read by motorists approaching from either direction. The "Stop" message then will not confuse the traffic moving in the opposite direction. The sixth and final situation deals with emergencies, such as an accident or a bridge out, where the proper equipment is not always readily available. However, in these situations, the public must be warned. Flaggers in emergency situations, but only in emergency situations, may use a 24 by 24-inch red flag for flagging operations. To stop traffic, the flag should be extended into the roadway. The flagger should raise the other hand in a stop position. To indicate that traffic should proceed, the flag should be dropped to the flagger's side and traffic waved through. Do not use the flag to wave traffic through. This confuses the driver. To alert and slow traffic, the flag should be waved from the ground to shoulder height. As soon as the proper equipment is available, the flag should no longer be used. As a supervisor, be sure that your flaggers understand their duties. Refer to the Manual on Uniform Traffic Control Devices for assistance. Decide which situations require flagging. If it's needed, don't allow work to begin until the flagger is on the job. Select the flagger carefully. Alertness, courtesy, neat appearance, intelligence, and a sense of responsibility are required. Be sure the flagger has the proper equipment and the flagger ahead signs are in place. Schedule hourly breaks for the flagger. Drive through the area and observe the flagger's operation. Close calls or skidding mean that the flagger station needs to be moved or that other problems exist. You may refer to FHWA's Flagging Handbook for additional information. The American Traffic Safety Services Association also has produced a pocket-sized flagging handbook, which you may want to obtain for your flaggers.
Remember, no matter what flagging procedure is used, always stay alert. Face oncoming traffic, stand alone in a good visible location, away from any work vehicle, and never stand in the path of approaching vehicles. Everyone, including motorists, fellow workers, and you, will depend on your ability to properly follow these flagging procedures.
Hey, did you go fishing last Saturday?
Yeah, sure did. Didn't have any luck, though. Missed a couple of nice ones.
Uh-huh.
Caught one little old scrawny bass, about a pound, pound and a half. But when that wind came up, buddy, we came in.
Hey, let me tell you, that wind caught me halfway across the lake. I thought I'd never get back. I did get 3 bass, though, so it was worth the trip. We fried them up when I got home, and man, they were good.
Hey, guys. How you
Hey,
doing?
Fred,
Hey,
how's
Fred.
it going?
How you doing?
I heard over the weekend that we weren't getting any raises next year. Have you heard that?
No. How come?
Well, apparently because of that bad traffic accident out on Broadway a couple of years ago. Well, the way I heard it, our lawyer sold us down the river. And the county just settled with the kid who ran out into that pavement cut.
Yeah, well, you know, I heard he got hurt pretty bad. But, you know, our signs were out there. Now, anybody who drives into a hole that big shouldn't be out there driving in the first place. Wait a minute. Hadn't he been to a party at the college or something like that?
Yeah, they said he wasn't too drunk. The way I remember it, they tested him and he wasn't legally drunk. But I do agree, with 2 signs and an obvious hole out there, it surely couldn't have been our fault.
No, I don't think so.
Morning, guys.
Oop, straighten up, fellas. Here comes the big boss.
Hey, Jack.
Jack?
How's it going, Jack?
Morning. How things going with y'all?
Well, it was pretty good until Fred started this business about not getting raises next year.
Yeah.
Is that true?
Oh, that's a distinct possibility. Looks like our budget's going to be real tight the next 2 or 3 years.
Is this all because of that accident that happened during construction out on Broadway?
Yeah, I'm afraid so. County settled that thing last week for over $700,000.
Wow, that's a lot.
Well, yeah, it's a lot, but, you know, he had some pretty bad injuries. He lost his right leg and lost the use of his right arm and hand. And the attorneys seemed to think we were pretty lucky to get out for the amount that we settled for. You know, he's a pretty smart young man, and he's not going to be able to work the rest of his life and support himself. And they felt like if it went to trial that we might have lost $3 or $4 million.
Oh, man, I don't believe this. I mean, of all the highway departments in the world, we get socked.
We aren't by ourselves, guys. I mean, state of Louisiana from 82 to 84 lost over $32 million in cases like this, and that didn't include what the cities and parishes lost down there. In 1989, state of California paid out over $36 million, and they had another $15 million in IOUs that they've got to pay when they get appropriations from the state. So we've got counties and cities and state governments all over the United States that are getting hit like this. In fact, we've had to pay out money before. This just the first time that we've had such a big amount that it really had an impact on our budget.
Well, didn't our construction people have their signs out?
Yes, there were some men working signs out there, but we didn't have an adequate number of cones to properly guide traffic by that curve in the road out there. You know, we didn't have anything out there to tell them of that lane shift. With all of that turning traffic that people had to watch out for, and all those flashing lights at the fast food places, and all that oncoming traffic, it was just difficult for a driver to see that curve in the road and to see that drop-off. In fact, if you consider the perception reaction time of the typical driver, we definitely should have had some advanced warning signs out there, warning of the curve and warning of the drop-off. Then we should have had barricades and cones to adequately channelize traffic through that work zone.
Yeah, but don't the construction signs cover us?
Well, we just haven't adequately let people know that we've got to follow the manual on uniform traffic control devices. Now, that's been adopted by our state as state law. And basically, the manual says you got to have more than men working signs up there most of the time.
But doesn't that only apply to like state highways and state highway department personnel?
Oh no, Carl. That manual applies on all roads and streets that are open to public travel. Doesn't matter whether they're state highways or county roads or city streets. It applies to all of them.
Huh. I didn't realize that.
Yeah, and if we don't follow the guidelines and the philosophy of that manual, then we're skating on thin ice. When that accident happens, it will, we better be following that manual.
Man, I'm glad I'm in maintenance, not construction. I don't know anything that's in that book. Oh, you construction guys have got it made. Your plans tell you what signs and barricades and pavement markings to use.
Yeah, but Mike, you and your people are supposed to be following that manual too. And it can help you an awful lot. In fact, that manual is for everybody. Construction people, maintenance people, our utility people, the police, sheriff's people, contractors, anybody working out there on that roadway or along that roadway that are doing work that might be hazardous to the public, got to follow that manual. It doesn't matter how long they're out there.
Yeah, but don't you think we do a really good job overall?
Yes, but we could do a better job. Frankly, we've been lucky so far. I've seen cases where we've had misleading pavement markings, or we haven't used enough cones or barricades to channelize traffic through the work area. I've seen cases where we've used flashing lights on barricades at night when we're supposed to use steady burning lights according to the manual. And then we'll put our devices out there sometimes and we don't maintain them. They get knocked over or pushed out of the way, or they get dirty. They don't show up at night. Things like that are especially bad for people like my father, who's 94 years old, still driving, and he needs a lot more light than he used to when he was a lot younger. And then there are other people that are out there. There are people on vacation that may be driving along, they're tired, or young people that are inexperienced, or somebody like maybe one of you guys that on the way home from work stopped and had a couple of beers. Not drunk now. You've stopped to have dinner and maybe you've had a drink along with your dinner. Those kinds of people are using the roads legally. And we have to design our work zones to accommodate those people. And even in fact, there might be a passenger in a car that's in a wreck. That passenger can sue the driver and the county, and they can win from both of us.
Jack, how can we make sure that this doesn't happen again?
Well, we're just going to have to do a much better job of training your people, Fred. And Carl and Mike's people, all of our construction and maintenance people are going to have to get adequate training in the manual. We're going to have to train our utility people, our police agencies. We're going to have to train contractors to make sure that they understand that the manual applies and that it applies to all of us when we're out there.
Now, the police are only out during emergencies. I mean, you mean the manual applies to them too?
Oh, absolutely. In fact, they're mentioned in the manual specifically. I know of a case a couple of years ago in a town where there had been an accident the night before, and the utility company the next day had to restring a power line across a major highway. Now, it wasn't an emergency at this time. They had time to get adequate signs and cones and barricades together, but they didn't. They called the police and said, come out and help us work and close this lane off. Well, they kept the lane closed for 4 or 5 hours. The police came out, they parked a police vehicle in the high-speed lane on a curve next to the median with no advance warning signs or anything. 55-mile-an-hour traffic. And, you know, the police testified that they didn't have any manuals or any training documents to tell them how to do this. They just used their common sense. Well, there was a young lady driving a car, came around the curve, saw the police vehicle parked in the high-speed lane. She tried to avoid it, lost control. She's now quadriplegic. I think her injuries were caused by the fact that the police and the utility didn't follow the manual. She sued the city, and she had a pretty large award. Now, we've got to learn from situations like this.
Well, Jack, you've given us all something to think about.
Yeah.
We all know that safety is the primary reason for setting up good traffic control. But you've just seen how the issue of liability is also extremely important to both your agency and yourself. Today, more than ever, work zone accidents are becoming courtroom lawsuits, with public agencies and their employees paying the price for improper traffic control. To help you avoid situations like you've just seen, here are 5 basic steps which you should follow to minimize your agency's exposure to lawsuits. Now, these steps are very simple and are based on good common sense. By following these steps, you'll also reduce the chances for accidents, injuries, and deaths in your work zones.
First, you should develop and use a traffic control plan for every job. The detail of this plan will depend on the size and complexity of the work. However, even for a simple 2-hour repair job, it's good to pre-think how to best handle traffic so that you'll have the proper devices and adequate personnel on hand. Second, always follow the guidelines in the Manual on Uniform Traffic Control Devices. Use traffic control devices which are standard in size, shape, color, and message. Third, try to use a work strategy that minimizes disruption of traffic flow. In particular, try to minimize the amount of time that workers and equipment are on the roadway. Also, don't expect all drivers to slow down at work zones, even when a reduced speed limit is posted. You must make work zones safe at prevailing traffic speeds. Fourth, promptly remove any traffic control devices which are no longer needed. Fifth, all personnel who install traffic control devices should receive training on the Manual on Uniform Traffic Control Devices and safe traffic handling procedures. Flaggers should receive prior instructions on proper flagging techniques.
It's also very important to inspect work zones to discover damaged or missing devices and to identify safety problems which may develop. Now, a good inspection program includes the following elements.
Day and nighttime inspections are essential, and they should be regularly scheduled. The number and frequency of inspections will depend on the location and type of work. Holiday and weekend inspections are also important since traffic accidents don't take a vacation. It's desirable to use an inspection report form. The report form will provide a record of your efforts to ensure safety, and it'll provide a checklist of items to look for. During the inspections, be on the constant lookout for potential safety hazards. Examples of hazard indicators include skid marks on the pavement, impact damage to traffic control devices, and/or undesirable driver actions. If damaged devices or other potential hazards are observed, it's critical to have the personnel and replacement devices readily available to make the needed repairs, day or night. There should be a procedure set up for making sure that needed repairs are made in a timely and proper manner. Finally, the entire inspection and repair process should be properly documented. Lawsuits resulting from work zone accidents often do not come to trial for a year or more. If you don't have written records, it may be very difficult to remember and prove what was done.
Not only is it important to keep written records of inspections, but it's also very important to record key items of information about every work zone. These include the starting and ending time of work, the location of the work, the type, condition, and position of traffic control devices, the names of personnel and the types of equipment used, and any changes in temporary or permanent regulatory traffic control devices. These items can be easily kept in a supervisor's or foreman's diary, even for small maintenance projects. It is recommended that more detailed information about work zone conditions be gathered and documented whenever there's an accident anywhere near the work area. This additional information could prove useful in the event of a lawsuit, and more importantly, it may help prevent future accidents.
Good morning, Joe.
Good morning, Worth. How are you this morning?
Pretty good. Doing all right?
It's going right good. Worth, what I want to talk to you about is they're going to have to tear out about 100 feet of this pavement down here on SR 1519. And we need to go down there and set up some signs for them. And what you're going to need to do is to carry 2 road constructions ahead, 1,500 feet.
Okay.
2 one-lane roads, 1,000 feet.
All right.
2 flags, 500 feet.
Okay.
2 stop and slow.
All right.
And approximately about 15 cones.
Think we'll take about 5 to 10 more extra ones in case we need them up there
That
too.
sounds good. Sounds
Okay, I'll
fine.
take about 20, 25 altogether.
And you're gonna have to carry, in a road construction, you're gonna have to carry 2 of those.
In construction. All right.
Work, this is kind of the basic ways you're gonna have to set that thing up down there.
Okay.
Yeah. And, I don't think you have any problem if you set it up like this. Go to your manual and set it up kind of like this. That's what we got it sketched off of you. You do have a manual.
We've got a manual on our truck.
Okay.
just like that.
I always refer back to your manual. This is how we got it sketched here. If you run into any kind of problem, just go back to your manual, and that's your basic way you do things. That's what I do.
Okay. I don't foresee any problem or anything.
You're gonna have to taper this thing now, Worth. Back here, we're gonna have a 400-foot buffer in here.
Okay. 400-foot buffers on, all right.
Yeah, just tape it off, kind of like you see it right here. Just come back 400 feet away from this job site. That's the reason I kind of sketched this off for you here, so you can see, you know, 400 feet,
Okay.
just like this.
You can work that out, all right.
Okay. Okay, now, you're gonna need the 2 flagons.
Have to have 2 flags. We can get an extra man from maintenance for helping us flag. I think we can take care of it, okay?
We'll check with them over it. And,
See if I can get a man from maintenance.
if they can't give you anybody to help you, you get back with me. I'll be around.
Okay.
And I'll get somebody to help you. And I want you to look at this now and see if there's anything you think we've left out that we need to do.
I don't see any problem with it. I think we.
And don't forget now to be sure to have your taper back, your buffement back here far enough so at least approximately 400 feet to keep them off and them people in there working in case they do go and run through you.
Okay, if I see any problem on it, I'll check out my material this afternoon.
If you run into any kind of problem, I don't mind calling me because, you know, I'll be glad to help you with it anyway.
Okay, we'll have that planned for next Monday morning at 8 o'clock.
Okay, that'll be fine.
First thing of the morning we arrive at work, if we've got a work order from our supervisors in Wilson, we'll first of all fill our sign order, what we have to go out in our equipment to work with. We load our post and proceed from the maintenance yard to the work site, and depending on whatever the situation may be, that's what we work on. Signing is a pretty important job. You got to make a decision, first of all, what type of sign you're putting out. And then the next thing is the location of where it's to be located. You know, the right footage from the road, get it out of the traffic area, you have people's driveways, you've got different places that you have to decide where the sign is to be put. Well, once in a while you get in heavy traffic, you'll wonder where you're going to get to try to work that particular zone, but most of the time on secondary roads we can handle it pretty good. See, we don't have any signing for our truck at all. All we've got is a safety flashing light and our safety blinkers. And that's basically all of the safety we have other than our hard hat and vest. And we have to sort of look out for the traffic, traveling public as well. You know how the public is. Generally, they just try to get by as fast as they can and keep going. Try not to slow down if they can help it. Average person doesn't really pay a lot of attention to the signs, but some of them do, and it's important that they see these signs and heed to the message that they're reading. If they don't, there could be some instances a lot of death involved if there were not signs involved. Safety is the most important thing of the road operation. That safety comes first, and signing is one of the most important things on the road. You've got to have your signing for your work area set up in a manner so that the public can see it well in advance of the work site, and It needs to be laid out in a proper manner, and I just think that's one of the most important things on the job, is safety.